Welcome to This Explainer. Today, we are diving straight into a massive, looming threat from our own star that could completely upend our modern way of life. You know, we rarely think about the sun as a direct danger to our daily routines, but as we're about to discover, the very foundation of our modern civilization is sitting directly in the crosshairs of cosmic weather.
Just look at the stark contrast here. Our modern existence relies completely on fragile technology that simply didn't exist 150 years ago. Back in the 19th century, human progress ran on telegraphs and steam power. If the sun acted up, well, maybe you'd see some unusually bright auroras in the sky, or perhaps a telegraph line would throw some sparks. But today, in the 21st century, we are entirely dependent on smartphones, intricate GPS networks, and vast global power grids. We've built this incredibly advanced world, but it's fundamentally vulnerable to the whims of space weather in a way our ancestors could literally never have imagined.
So that brings us to a pretty terrifying scenario highlighted in a recently cited 2026 British technical report. What exactly happens to us if a once-in-a-century solar event strikes Earth today? And honestly, it's not a matter of if, but when. We know these massive events happen roughly once every 100 years on average, so if a centennial storm erupts tomorrow, does it literally send us back to the 19th century?
Here is our roadmap for today. 1. Our technological reliance. 2. Threats to infrastructure. 3. Mechanics of solar storms. And 4. Monitoring our star.
Let's kick things off with Section 1, our technological reliance. We all use smartphones, navigation, and power grids daily without a second thought, right? I mean, you probably used GPS just to get to a new restaurant last week or checked a highly accurate weather forecast. But researchers are warning us that this reliance is kind of our Achilles heel. That 2026 British technical report specifically examined the consequences of a major 1-in-100-year solar event. And while this specific study focused on the UK, the researchers made it crystal clear. Regions at similar latitudes globally are all highly vulnerable to a massive solar disruption. The indispensable technologies we rely on aren't just at risk of a temporary glitch, they could be entirely destroyed.
Moving right along to Section 2, Threats to Infrastructure. Take a second to grasp the sheer scale of the chaos in this NASA mapping. We are absolutely not just talking about a dropped phone call here. This shows everything from airline passenger radiation exposure to massive telecommunications cable disruptions deep under the ocean. It is a multi-layered attack from space, affecting both our assets up in orbit and our critical systems down here on the surface.
Let's actually break down these specific infrastructure casualties. When a powerful geomagnetic storm hits, it induces massive, completely unwanted electrical currents straight into our high-voltage power lines. This sudden surge overloads the system, directly leading to severe regional power outages. And up in orbit, it's just as bad. An influx of energetic particles degrades satellite electronics and severely shortens the lifespan of their solar panels. That means a sudden loss of GPS and crucial weather satellite data. And if that wasn't enough, solar flares scramble our radio communications, meaning long-distance radio links used by airplanes and ships can be degraded or completely lost for days at a time.
Now you might be sitting there thinking, okay, this all sounds like a sci-fi movie, but this isn't just theory. In May 2024, an extreme solar event occurred. And the result? The U.S. agricultural sector suffered significant financial losses precisely because crucial satellite guidance systems, literally the exact systems farmers rely on to plant and harvest efficiently, failed entirely during the event. Real dollars, real food supplies, directly impacted by the sun. And hey, the threat to our satellites goes way beyond just fried electronics. Look at this incredible image captured over Puerto Rico in February 2022. When intense solar X-rays hit Earth, they actually heat up our upper atmosphere. And when the atmosphere heats up, it swells outward like a giant balloon. This sudden expansion creates unexpected drag on spacecraft in low Earth orbit. It literally pulls satellites right out of their paths, forcing them into an uncontrolled fiery descent where they just burn up as space debris. It is a stark visual reminder of the sheer physical power of space weather. Which brings us to Section 3, Mechanics of Solar Storms. To really understand this threat, we've got to understand the weapon itself. And that weapon is primarily the coronal mass ejection, or CME. These are massive, colossal clouds of plasma that are violently ejected from the sun's atmosphere. And they don't just gently drift out into space, they are launched at millions of kilometers per hour. Despite the vast distance between us and the sun, these high-speed plasma clouds take just a few days to cross the void and reach Earth. So how exactly does a CME form? Well, the sun's activity isn't constant. It follows a roughly 11-year cycle of calm and intense agitation. During the active phases, these 4 steps play out. First, dark sunspots appear on the surface. These are areas of highly complex, tangled magnetic fields. Second, these twisted magnetic fields abruptly snap and reconnect, releasing phenomenal amounts of energy. Third, this explosion can launch those plasma clouds, the CMEs, out into space. And finally, when those clouds reach us, step 4 happens. Our planet's magnetic shield is violently compressed and deformed. This violent compression is what triggers those beautiful polar auroras. But as we've learned, it also triggers those incredibly dangerous electrical currents on the ground.
Finally, let's hit section 4, monitoring our star.
The good news here? Scientists are absolutely not flying blind. We have an entire fleet of space and ground observatories that are constantly watching the sun. Satellites like NASA's Solar Dynamics Observatory provide continuous, real-time imaging to detect the very first warning signs of solar eruptions. But observation alone isn't enough. Researchers are constantly developing and refining advanced computer models to simulate exactly where these plasma clouds are heading once they launch, predicting their strength and direction as they travel through the solar system.
And this continuous surveillance is absolutely critical. As the source material highlights, this monitoring helps issue alerts, offering a precious few hours of reaction time. Honestly, that's the whole ballgame right there. We can't stop a solar storm, but those few vital hours before the fastest particles arrive are all grid operators and satellite managers have to shield critical infrastructure, adjust orbits, or strategically power down systems to prevent physical destruction.
As we wrap up this explainer, I want to leave you with a pretty chilling thought. Our monitoring is incredible, and our computer models are getting better every single year. But when that massive, inevitable centennial storm finally erupts, the 1-in-100-year event, will a few hours truly be enough? Are we really ready as a global society to rapidly unplug our entire modern civilization to save it from the very star that gives us life? It's a question we desperately need to answer before the sky lights up.